Okay, well, welcome back, and here we go. So, we learned about the polyatomic ions, and basically, there's absolutely no difference between the polyatomic ions and an ion for a single element. So, we're going to look up here on the periodic table, and I included this on the top of the sheet because I thought it'd make it easier on you. And we see the potassium is K, and it's in family 1, so it has an oxidation number of 1 plus. And we see this as acetate, so we look up here, acetate is C2H3O2. Oh, violated the first law here. This is supposed to be capital. And we need to have it in parentheses. We're going to keep it in parentheses just like we see up here. And its oxidation number is 1 negative. So now to come up with our formula, we're going to take the potassium and we're going to take the acetate, the C2H3O2, C3O2, okay, and we're going to take this 1 and move it down over here. So again, what we said before, this 1 is going to go down on the outside of the parentheses, and this 1 is going to go here, and we drop the signs. So this is going to be a 1 and a 1. That's it. Okay? And in the name, because this is a polyatomic ion, you do not need to do the IDE on the end. So this is potassium, and it's potassium acetate. This one says ammonium and chlorine, so now this is important right here. It says ammonium chloride. Chloride, remember, if it's an element, we put IDE on the end. So this is really ammonium and chlorine. We're going to look up here. Ammonium doesn't sound like any of the elements we've worked with. We look up here and see it is a polyatomic ion, and it's NH4. And we look on the chart, and its oxidation number is 1 plus. Okay. Now, chlorine, like we said, its symbol is Cl, and it's over here in family 7, and it has an oxidation number 1 minus. So to come up with the formula, we take the NH4, and the other element is Cl. And remember we said we're going to take this 1, and we're going to stick it down here, and this 1, and we're going to stick it over there. So, I mean, they're both 1 in this case, so really it doesn't matter. They're both 1, and then the name of this substance is going to be just what it says it is. It's ammonium chloride. Okay, the next one says magnesium sulfate. So we know magnesium's an element. We look up here, it's in family 2, and its symbol is Mg, and it has an oxidation number of 2 plus. And we look for sulfate here, it's SO4, and its oxidation number is 2 minus. Okay, now, normally we would just take this 2 and put it down here, and this 2 and put it down here. This is kind of like in math, you need to simplify. Because what we're really thinking is, how many positive 2's does it take to cancel a negative 2? Well, this can be simplified. It takes 1 positive 2 to cancel 1 negative 2. So, and then the name of the substance, if it's a polyatomic ion, we don't need to change the name, so it's magnesium and sulfate. Okay. The next one says that we're doing calcium carbonate. Okay, so we look up here on the symbol, calcium is Ca, and it's in family 2, so it has an oxidation number of 2 plus. We look for carbonate. Carbonate is right here, it's CO3. And what's its oxidation number? It's 2 minus. Now, we're going to put the symbols over here. And again, it's going to take one positive 2 to cancel one negative 2. So these are going to be simplified. And I put a little reminder in here. As you work, you can hit these plays and it'll tell you. Okay, so the name of this substance is calcium. It's carbonate. And so if it's a polyatomic ion, okay, we don't need to change the name of the second one. This next one says we're doing potassium and hydroxide. Hydroxide does not sound like an element, so we know we need to look in the polyatomic chart. We find potassium is over here in family 1, so its oxidation number is 1 plus. And we look for hydroxide. Hydroxide is OH. And its oxidation number is 1 minus. Okay, so now to make our formula, we take the K, and we need the OH, and we're leaving it in parentheses. We never touch anything inside a polyatomic ion. The whole thing, including the parentheses, works just like an element symbol, so we wouldn't change the letters. We don't change that. And we're going to take this 1 and put it down and across. We're going to take this 1 and put it down and across. Remember, we're just crisscrossing these numbers. Okay. And then the name of this stuff is, in this case, it's not like the ones with elements. Its name doesn't change. It's potassium hydroxide. The next one says calcium hydroxide. Okay, so we look. Calcium is in family 2, so it's Ca. And it's a capital C because it's an element. And the hydroxide is OH. And the calcium's oxidation number was 2 plus. And the hydroxide's oxidation number, we look at the chart, is 1 negative. So we're going to put the symbols over here. Okay. And then we're going to take this 2. This is when we're going to move it down and across. This 2 is going to come here. And this 1 is going to go right there. So we're going to put them in over here. And put in the 1 and the 2. And since this is a polyatomic ion, we don't change the name. And that's it. Okay, the next one says we're doing potassium carbonate. If you look on the periodic table here, potassium is in family 1 with an oxidation number of 1. And the carbonate is right here. It's CO3 with an oxidation number of 2 minus. And now to make the formula, we take the K, and we have CO3. And we're going to crisscross the numbers, okay? And so we're going to take this 1 and move it over here. And we're going to take this 2 and move it down over here. So when we put it in, the 2 is going to go here, and the 1 is going to go there. So we have 2. We'll crisscross and drop the signs. And then we have potassium. And it's carbonate. Okay. And then the next one is ammonium phosphate. So neither one of, it's aluminum phosphate. So we look up here, aluminum on the periodic table is in family 3, and it has an oxidation number 3 plus. Okay, and we need to find the phosphate. So we look up here, there it is, phosphate is PO4, and its oxidation number is 3 minus. Okay, so to make the formula, And again, it's going to take one positive 3 to cancel one negative 3. So the name of the substance is going to be aluminum and it's phosphate. Because it's a polyatomic, we don't change the name. Okay? Nope. All right. The next one is sodium phosphate. So it's actually the same as this PO4 here. So we can go ahead and use the information from the last problem. And we already know that PO4 is a 3 minus. So we got to find sodium. We're going to look on the periodic table. Sodium's in family 1, and its oxidation number is 1 plus. Sodium, 1 plus. So we're going to put that in here, and A, and its oxidation number is 1 plus. So we're going to come over here, we have Na, and we have the PO4. Now to make the formula, again, this is where we're going to do the little crisscross thing. We're going to put the 1 here. We're going to take and put the 3. And put the 3 over here. Okay? So we got the 1 goes here. And the 3 goes here. And the name of this stuff is going to be sodium phosphate. Now the last one is magnesium sulfate, and I see that magnesium is here in family 2, and it has an oxidation number 2 plus. And I'm going to look, and sulfate is SO4. And its oxidation number is 2 minus. Okay, so I'm going to come over here, and I'm going to have Mg, and I'm going to have the SO4, and then the 2's are going to come across, but remember it takes one positive 2 to cancel one negative 2, and the name of the substance is going to be magnesium. And that's all there is to naming polyatomic ions and compounds.